My name is Amanda Shafer, and I am a cake designer. I bake cakes, bake weddings, celebration, novelty, all different kinds of cakes, and I decorate them, design them. I use math all throughout all the aspects of my job. From the beginning, I use math while baking, measuring, weighing. I use math to determine how much batter I need. I use it to determine the amount of servings I would need in a cake, what size cakes to use, and I use math while designing a cake for proportions, balance, things of that nature. When I was in school, I didn't think my math classes would relate to what I would end up doing as a career at all. I thought that I just needed to take them, and that the basics was all that I would need to know, and because I had no interest in pursuing a career in math. So when I'm determining for a cake how many slices of a cake I need, if someone comes to me and says, I need 32 slices of cake for my party, I need to go and figure out what size cake they need that would accommodate that many slices. So in order to do that, I have to find the volume of a round cake. So I would take a 12-inch cake, and I would take the radius of it, which is 6, and I would square that, so 6 times 6, and multiply that times pi, and then times the height of the cake. And that would give me the volume. And then to further find the slice, I would have to find the volume of the slice. And once I have those two numbers, the volume of the cake and the volume of the slice, I would divide the volume of the cake by the volume of the slice. And that would give me my servings. My cakes are made in all different shapes. The more common ones are round and square. You can do hexagons, ovals, petals, wide variety, and when you get into the more unique shapes, the math gets even harder, and that's where I find myself having to go towards other resources to either learn how to break down a hexagon to find the volume, or something that I rely on is going back to the basics in a situation like that and actually breaking the hexagon down into smaller shapes within that. The most important part for me in solving a math problem would be that the end product, my client's product, relies on the fact that the equation is correct. That my business, my whole reputation depends on the fact that I can deliver something that involves an equation. It has to be right. Proportional reasoning is another tool I use when doing design, decorating. With a cake, when you're looking at especially a stacked cake, a tiered cake, all of the cakes need to be the same height so that it's pleasing to the eye, which mathematically is pleasing. They're both the same. And there's a constant difference in the sizes of the tiers. So if you have a 6-inch, an 8-inch, and a 10-inch round, they'll have 2 inches between them. If you threw a 4-inch on the top rather than a 6, it would look off because the math is off. And so your eye, it's not as pleasing to your eye. And proportion's actually a big thing with cake decorating too, because you want it to fill the space. You want everything to be in relation to everything else appropriately. Another one, a way that I use math specifically, is reflections with designs. If I have a particular design on a cake and I want to reflect it, I have to flip the whole design and make sure that it's even on both sides and the exact mirror image. Or if I want to take that design and rotate it, putting it in different ways on the cake. It's a great decorating tool, and it's a really basic math concept.